Welcome to a new test and teardown video. Yeah, I also got the next one in this series. This is the HP Signal Generator model 618C. Yeah, HF is super high frequency. So this one covers from 3800 to 7600 megahertz. So far I've just been checking mains voltage and lifted it out the case. There are a few things I need to investigate before I power this up. I went through all the dials and buttons, and everything else here seems to be working. Those goes a little bit tight, so I guess this was stored in a high humidity cellar because of the corrosion on the aluminium feed. But I have a problem with those two here. The output attenuator and the power set, they're just frozen somehow. So I guess there's like maybe corrosion or some other things. I need to look into this. Also, this unit is a lot bigger compared to the other models. Yeah, I mean, its height is a lot bigger. It got the calibrated and a non-calibrated output. And this is actually before or after the output attenuator, or this is like a parallel output. So this is full power output. Just be aware of that, so that this one can actually be quite powerful, plus some dBms. So that is what I need to be a little bit afraid of. I don't know if I'm afraid, but be a little bit afraid is a good idea. Anyway, let's take it up on the table and have a look. What is wrong with this? So this is the rear side. I just took off the 4 screws here on the back. I think they go through the outer chassis and then they go into the internal parts, so you need to take those out. But look, they're completely corroded. I think they are made of aluminium of some sort, and this unit was probably put on a wet concrete floor or something like that. So I need to clean up all this corrosion. Hui. This one was nice and dry. Isn't that funny? But the others, they are really bad. I need to service this a little bit. Hui. Not only is it bigger, it's also a lot more heavy. I decided to look a little bit more into it here on the floor. It looks a lot different. All those pot meters and stuff, they're normally located this far in, but now it's a lot more compact when it comes to all that. And here we got, yeah, everything is just a completely different layout. We got all them tubes here at the back. They're all nicely shielded. I kind of like that. But sometimes it's a lot easier if you can see the glow in the tubes. I use this a lot when I play with vintage equipment, just to look at stuff, you know it's powered correctly. It's not blown up or anything. But it looks quite alright. Those little white dots here is something you need to clean up. Probably some high voltage. So there's maybe moisture from the air or some salt from the air that went in there. So better clean this up before we get a flashover or something like that. And then all the stock stuff is in this unit here. Maybe I don't know if I can remove the output. Damn it, it's not that easy to get in here. This is an inside view of the left side. We are looking into the stock attenuator stuff. And that will be the 2 stock screws, or so they kind of go in here, so there will be some gearboxes and stuff in here, but maybe the whole problem is this shaft that goes to the main thing here. Maybe if I loosen those two screws so this shaft can rotate, then I can see where the stock is, or where it is stuck. And those long tubes with the holes here, that would be air ventilation out of the resonant chamber. That is pretty funny, the way they made this. So this is the frequency adjustments. Look at that clockwork. A lot of gears. But this runs really nice and smooth, so that would probably be access to some of the moving parts in here. So we can go and have a look in here. But I need to get in here and see if I can fix this stuck problem, because other than that, it's no fun. There's a connector here, so that means I can unplug this and maybe tilt down the entire front panel to access everything. So that is a good idea. And this is the right side of the frequency adjustment, and this is what they call repeller adjust. What I believe this has something to do with the grid and anode voltages, and those needs to be variable depending on the frequency you want. All the way from the 300 to, I think it was 900, it's going more or less linear all the way up. So this you can adjust here, so it's gonna be more or less correct. Now we see some transistors as well, and this is because this unit was initially designed in the 1950s, but this one is from the 80s. This is the C model, right? This is the bottom view of this unit. We got 3 different power supply units in sockets. That is actually quite interesting. 2 of them looks very identical, and the other one looks like something completely different. This I need to look a little bit into. And then no, what is it up here? No, I didn't find anything fancy here, but we see all the shielded tubes and stuff. And now, what is that thingy? I believe this is a special tool. See, we can unscrew this and take out this tool. So this tool can do something. This is probably for accessing something. I like it. A tool. HP is famous for hiding all sorts of tools or helping things in their units, so why not? Some special tools, right? Oh my god, this unit is really a lot deeper and a lot heavier. It is some tough thicknesses, and this mains transformator is just gigantic big. Look here. This is probably a lot of kilos. Why is it so big? Maybe we should try and pull out some of the power supplies and have a look. I'm a little bit worried about those caps looking sweaty. I've taken out the power supply boards. This one is the one to the right. They look a lot identical on the first look, but they're not exactly identical, right? So we got some voltage regulator choose amplifier and feedback. So yeah, this is definitely a regulated high voltage supply, and this is the same, but just for higher current. Those two are actually in parallel. I've been sneak peeking a little bit in the schematic, and again you see voltage regulator tube. Yep. And then, oops, this one here is the first one. Also got some, yeah, this is also a voltage regulator tube, yeah, definitely, and yeah, the feedback circuits and the voltage regulation. So yeah, all in all, 3 little power supply plug-in boards, and the rest is just done the old-fashioned way. So they are mixing technologies a lot. This is the old style from the 50s, and then yeah, okay, let's upgrade a little bit and make some of the stuff new and cool. Yeah, let's use some PCBs. But this one model here was made all the way up to the 80s. Why are we still using tubes? That's funny, isn't it? I'm still thinking a lot about how I need to address the stock problem here, because what I see is actually 2 shafts inside. Well, this one is inside that one, right? And then we got those 2 gears connected to each side of this, the thin and the thicker shaft. And then we got the 2 different attenuator outputs. So these 2 actually moves up probably at a different rate, and one goes to the output and the other one goes to the calibrator. I don't know if I can show you guys this a little bit clearer from the side. Yeah, maybe. Let me see if I can move the light a little bit. But you see, we got 2 different couplers, right? So they will of course be geared at a different rate. So I think I need to mark where everything is carefully, and then I need to see if I can unscrew all the set screws and see if that will allow me to dial in all the clockwork from the outside. Because I need to know, where is the problem? Is it in all the gearboxes and stuff out here, or is it in here somewhere? Where is it stuck? Oh no, this is going to be difficult. So here's my theory. I hope you enjoy the idea, or at least agree. See, I added a little bit of red dots up here as well. Up here you see red dots and red dots here. So that means from this view I should be able to hit more or less the same spot, because this is exactly outside of it, right? So they kind of line up, all of them. So at least this is my idea. Let's hope I'm not making a big fool out of myself. Of course, I also need to record where the outside dial is, and I actually also needed to add some lines on all the shafts. Ooh, difficult. And here we go. Now we can move it. So it's the outside gearbox that is causing all the problems. Great! Now I just need to figure out how to get that one out. Ooh, that is difficult. Oh, one more thing that I found. Hehe, a novistor. That is nice. And also, I found this one. It really burned resistor. But why is it that the PCB looks so burnt, but that resistor looks nice and... Ooh, it's cracked! Look at that! Hey, remove this wire. Thank you. Ooh, that resistor is cracked. That is something we can easily fix. Aha, and it's looking like it's in series with the other resistor, and that one is looking nice and fine. Okay, that is interesting. I need to remember to deal with that in a later moment. Oh, all this mechanics and funny stuff that moves. Isn't it just lovely? Look at that. Now it's empty in here. I actually managed to get the entire clockwork out. Look, it is corroded, or what is that kind of slime here? And there's a thing. There's actually quite a lot of space in here if you stick your hand up here. And this was my exit path. This wire is a little bit in the way, but there is I need to be careful with the two couplers here. See, they can of course move and all that. So I unscrewed all the gears here, and there was actually a screw down here as well. Imagine getting in here and all the way around here, and then to here on the front. I just unscrewed everything here, and here is the clockwork, and this is completely stuck somehow. I am not able to find exactly what is going on. This is the dial, so that one moves a little bit, but I think I need to disassemble everything and see if I can put it back together. Well, I came with something that didn't work, so if it continues not to work, I still have something that still don't work. So this is of course required to be able to handle the output levels, and if this doesn't work, I think the whole unit is not worth anything anyway. So it looks a lot like somebody poked the dials around. See, that was supposed to be the stop, but it was by brute force moved all the way around. This is of course not how it's supposed to be. So I guess that is one of the problems, right? It was poked all the way around. And what have this caused of secondary problem? Why is it stuck? Alright, you need to fast forward this video a little bit if you don't like to fool around with all sorts of gearboxes or mechanics. But this is just a part of working with vintage equipment, so I'm just trying to video this at least so I can put it back together. I was able to finally pull off here we got the exit gearbox, or the exit gears on the end here, right? And that means now I can move these two. I move this up a little bit, put this up, and the other one a little bit up and free. See, they move perfectly fine. So now I got those three, they're completely stuck, and they go through a lot of aluminium here, and I think there's like grease of some sort in there that just turned to epoxy or something. I got another annoying problem with this one, and it is the look at the back side of the knobs. This one was the OK knob. Those little brass inserts, they're actually loose in here, and they sit there by the two set screws. So I took out the two set screws in the other one here, so I didn't break this I think it's bakelite or something like that, so it's a little bit fragile, brittle. But this piece of brass is also very, very soft. When I try and grab this a little bit, it just goes to butter, and it's super stuck here. I can easily turn it around, but there's no way to move it. So you can only move it a little bit back and forward, and there's just no more than that. No matter what kind of brute force I use. I also try and stick in a metal piece in here and then twist it. It's just not going off. But this one I need to take off, otherwise there's no way I can get these out. And then I need to get in there. Hey, so this is the never-ending story of difficulties. But I think here we got our grease, and it is definitely turned to, I don't know, old chewing gum probably. Yeah, it is really, really stiffy. With some hair in it as well. You can imagine it's not moving a lot. I don't know if I would call this the fight of my life, but it was definitely a fight of one whole night. To get those 3 out. Are you kidding me? So this kind of the old grease turned into epoxy or something like that. It was just stuck. Everything was stuck. And of course it didn't help. If you look at, I think, see, this is the down one. They're different. So some goes down and one goes up. And of course put a little marking here so I can remember what is what. And also I got some really good video clips, so it should be fairly easy to mount this again. But yeah, you see, this was the front panel one with the set screws in, I think it was in this one, right? And somebody, of course, tried to turn and turn and turn on the knob. And when nothing on the dials change, they just turn some more. And of course the set screws are gonna grind a lot in here. And that is why this one was impossible to take out, because they, I don't know, made some really nasty marks in this steel. So that is really what you don't want to do. And yeah, of course I got those out using heat. So my nice little gas thrower could actually heat up this aluminium, and then I was able to take them out. But it was only like almost invisible, as slow as it went, and I needed to heat this up, so it was impossible to touch. And oh man, it took hours per one of these. Anyway, out it is, and all the parts, they were, I don't know if you can remember this earlier from the video, how gross everything was. Now it's all nice and clean. All the parts here, there, it's full of ball bearings and stuff to make it really, really nice. And all the gears now super nice and clean. I look so much forward to lubricating everything and assembling everything here. I hope I got all the notes that I needed to make it correct. Where is this last piece? Oh, I got it in my pocket. Well, that's funny, because I was out cleaning those things. And to clean all this, I found a paintbrush and acetone. That is the trick. So to get this sticky stuff away. And here we got the 2 main wheels with the anti-backslash systems. And what do you know? There's also ball bearings, see, in here. So they just went all the way for niceness and coolness. I love it. Full of ball bearings and things. So when all this is assembled again, I look forward to see if it works. Oh yeah. I believe I found a design bug in this unit. Because look at that. This gear is not able to get into the anti-backslash, because when this is assembled, it only touches the bottom part of the anti-backslashes, and those 2 parts, they're all the way together. There's no way the top gear can go even further down. That is just impossible. And this gear is, oh, let me take it out and show you guys this. So here is a side view. So this is how it is aligned when this part touches the bottom part of that one, and this one is also all the way in here, so there's no other way to get even further down, right? So, and look at the width of this one, how narrow it is. It is not able to touch both parts or grip into both parts of the anti-backslash. And if I lift this up, or even if I put it in the middle, look what's gonna happen. The set screws, they're gonna jump into the gear here. So that is also not going to work. So when they cut this, they should have made this like 3 millimeters higher. There's like tons of space up here, and then the anti-backslash would work. So that is definitely a design bug that I'm not able to fix in any way. I can only put it where it's supposed to be. No. Well. So now I'm ready to assemble this. All I have to do is stick those 3 shafts through those 3 holes, and then we're done, right? But I also need this one to be on the center point here. And there's only a tiny little bit of that other shaft that actually sticks through here, and that goes through this hole. So my idea is to stick a lot of ball bearing grease on this, so it's gonna stick, and then hopefully I can assemble it, because it was already super greased in there when I pulled it apart. So I guess that was kind of the trick they used as well. So now everything is assembled, and I'm ready to power this unit up. I didn't tighten any of the set screws, so that means the 2 couplers, they are free to move, and the 2 shafts here, they're free to move if I touch the front panel. So you can see this is the rear shaft, this is the front one. So now we'll power it up and see if anything is working, and then I will first just put them so that I get tons of output all the way in, and then I will tighten the set screws, and I will tighten the readout dials as well. They're completely free to move, so that is how it's supposed to be. I was about to power this up, and then I realized the power supply connectors, they come in different sizes for this one, right? Look what I got. 2 different sizes, and they look, I don't know how identical they look. I don't know if you can see this, but one of them is just a millimeter bigger. Will not fit. Damn it. So everything is just one big annoying delay here. This one fits. This will just drive everybody nuts. They thought they got the right one, and it really looks like the right one, but it's not gonna go in. Annoying. As I always promised to power on while radio recording, because you never know what's gonna happen. So nothing. So hello. But I didn't check the fuse. That was not funny. Okay, I need to investigate. I'm sorry, I know now why it didn't power up. There's of course this connector here I pulled like a week ago when I started to play with all the mechanical things. So that's probably why. Alright, let's try again. No kaboom. 163 watts. 103. So what I'm looking for is a response on the power meter. I did not dial anything anywhere. I hope just 160 watts. It's going up again, and we don't see anything. That will be the pulses. This is a modulation selector. I put it for 7.4 gigahertz. What I could do is put on a spectral analyzer and see if there's any signal. But I sure was expecting something here. That is not good. 170 watts, and it is quite stable here. All right, I'll boot up. So I believe we can trust this meter as a no power output, because what I see here is absolutely nothing, and this is from 4 to 8 gigahertz, and there's absolutely no signal whatsoever, and there isn't anything that I can do. Modulation selector, this has something to do with that. There's no signals. Nothing is coming out of this thing. So I'm definitely missing some voltages for the oscillator. That is a little bit sad. Now I spent a whole week figuring out how to do all the mechanical stuff. But at least all this is nice and shiny. Oh no. So that will be next episode. Just to prove that it's not me who's crazy, I just took the old one. So when I set the output for 2 gigahertz, just cranked up the output. So this is a 2 gigahertz signal on this spectrum analyzer, and I think this is also quite nasty. The range of this beast. So this is a 5.6 gigahertz signal. Yay! About 5.6 gigahertz here as well. Alright, so it is alive now. And there's still no reading. So there's something with the modulation and the... Oh, it's really dark. Something about the modulation and the voltage and current and feedback and controlling of this oscillator. And clearly it is like this if I now dial the frequency. See? Ooh, I can move it. And if I crank it down too much and then, whoops. See, this oscillator stops and now I go back. And it goes more powerful and then it goes away again. I guess. Yeah, so there is some voltages and some power supplies. I need to figure out exactly what is going on. But I think this video has already been a little bit too long and boring. So I don't know what I will do, if I will stop it or if I will continue again tomorrow. We will see. I'm also going on a little bit of experiment mode and using my thermal camera to see where are all the hot and dangerous items. I see some stuff down here, and so I'm going to hunt down. Let's see, that is the power resistor, and this is the nuvistor. So there was a nuvistor hidden in here. That's pretty nice as well. I'm going to hunt down 2 hot components and look at all the different things that I can probably find. I don't know if I'm... it's difficult to show you guys this on a camera-to-camera kind of thing here. But I'm a little bit worried about this power resistor down here. That is probably broken, and that is probably also involved in this regulation that is not working. Also, I have not yet measured any voltages at all. I need to go and look in the manual, find all the different test points and see about all that. It's probably why we don't see this meter working, and we don't have a regulation about the output power as well. That resistor down there, that was 300 degrees hot when this thing was on. I just turned it off. So of course now it's going to cool down. But that has something to do with my problem, right? You can't have 300 degrees hot resistors. That is not good. So this is the power detector. They call this a bolometer power detector. That means it's a temperature sensor. It senses the power here, and it is converted into a DC voltage, as far as I understand. And then this here is the connector that was connected to that one, right? So this is the PCB that is in fact the power regulator, and if you see on the top of this PCB, it is called 618-632. Ta-ta! Exactly what we see in the schematic. But look at that. This resistor is 601, 602, right? Where are they? They are not on this. All I can see here, this is the input. It's supposed to go directly to 602. That is that one. And that will be the base. Oh, look at that. So this is a double. This is a 2-in-1 balanced transistor. This is also what we see here. So those will be a balanced pair and those will be a balanced pair, right? So anyway, one of them, this is the input, is the white wire, and it goes to the center pin of that transistor. So that is fantastic. So the ground pin goes to a CR601. CR601 is here, right? So CR601 is directly to plus 5 volts, and then it's supposed to be ground on the other side. So this is ground, right? But I don't find those two resistors. So they're probably not on this. So this is another board, or where are they? Oh man, this is a little bit annoying. It was not supposed to be this difficult. But there's definitely something wrong here. Too much voltage, right? So what if we got too much voltage coming in here? And also I don't see this very good explained. 6, 8, 4, 3. But we got 9 pins on this PCB, right? So what is the trick? 9 is not used. Okay, so 8 is used. That is probably ground, yeah. Hey, man. I didn't want these kind of difficulties. I want easy. So this is the thrystron. And this is the resonant chamber in there. Those are the variable couplers for the attenuator output and the power calibration. Here in the bottom there is this output sniffer that goes to the on-cal output. So this is a fixed output. And let's try and open this thing. So this is what I did. So this one goes on top here, and there's a nice connector. It's connected to the bottom. And as far as I understand, we can either... Yes, we can. Let's have a look in here. Ooh, that is nice. So we're getting closer. And I believe the wrench that we found, where was it? Here. Haha, now I know what that is for. What do you know? This tool fits here. I believe, yes. This is definitely the way to get in there. And what have we got in the magic secret chamber of all the funny things? Ooh. Why is this wet? That can't be right. Oh, it is coming up. Oi, 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 oi. See, that is one beautiful tube. How about that? Look at all those. Oh, that is some nice. It's actually still warm. It's quite a long time ago since I was playing with this. But I really wanted you to see this super, super cute. Think about it. This thing can do 7 gigahertz. That is a little bit amazing. Yep, and if we look inside the hole here, we do see the connections to the different parts. I think this is the last bit of coolness I can show you guys. Oh, this is nice. Oh, by the way, here is the last electrode for the tube. and this goes through this. I believe this is an inductor and a capacitor, and in here it is, I believe, connected with a wire or something. Maybe we got actually another one. I think I see. Is that a blue wire we see here? Let's have a look. Anyway, this is the frequency adjustment. What do you think about this? So right now I'm going down in frequency, 4 gigahertz, 3 gigahertz. So, and this is what pulls the resonator longer and longer and longer, right? So of course the frequency is lower. Yeah, okay, so this is the wire. This one of course goes all the way up and touches the top tip of the tube. Isn't that just cute? And what do you know? Oh, this is brass, and those are milled with threads that goes each way, and wow, look at the mechanics. It's just beautiful. There's like, so this is the wheel that I turn when I turn the frequency, right? This goes directly in here. So this is the readout wheel, but this is only half of it. See, there's another one. So this one must be located about here, right? And then it touches a bigger one that turns this dial. Oh yes, and this runs a little. Okay, I can still see that the grease out here turned a little bit hard, but in here it's completely sealed, and I believe this is. No, it's actually still not perfect, but all right. Big good ball bearings and all the coolest things you can imagine, and big solid casted. And it did something really cool about this design. See all the capacitors, how they're located far away from all the tubes. So of course they don't want to heat up the capacitors more than absolutely necessary. And that is a brilliant way of thinking. And now it's all assembled. And the mechanics is just absolutely fantastic. It's just so nice and loose. Easy adjustments. So those two are now, this one and that one. Nice. I love it.